Hopefully you've encountered databases before or you've worked with some kind of structured data in the past. But we're going to talk about some of the terms that we need to think about when we're working with structured data before we jump into actually analyzing, extracting, working with some of the structured data. So some of the terms, we're going to cover each one of these in the next few minutes. Denormalization versus normalization, which is an important concept because I'll tell you, when I started learning about databases, I thought everything should be normalized all the time. And it took several years into my career before I really could kind of identify and understand the value of denormalization, which, when you're working with an operational database, is not really a good thing to do. We'll talk about IDs, keys, and referential integrity. We'll talk about indexing. We'll talk about metadata, and we'll talk about data warehousing, where that concept of denormalization is going to come up again. So denormalization versus normalization. So normalization is really when we are trying to eliminate data in a database. So if you think about a really simple record keeping system, let's say you have a bunch of employees and you're trying to identify information about your employees, and you want their address, and maybe you want information about their degrees, and maybe you want information about some of their skills. If you put all of that in a single record, you're going to run into problems right away. Like, what happens if an employee has more degrees than we have allocated space for, allocated structure for in our data storage system? Now you kind of have to think about how we're going to normalize this. So typically the process of normalization involves taking all of those different pieces and breaking them out into their own tables or their own entities. So normalizing data, we eliminate that redundant data. Otherwise, if we had to put 1 degree in each field, we'd have 4 or 5 records for each employee if they had 4 or 5 degrees and if they have multiple skills. So you can kind of see how this duplication problem is going to be challenging. Not to mention that if we start duplicating the data in that way, updates are going to become much more complicated. So denormalized data has repeated entries. With denormalized data, we actually want to have duplicates. The duplicates are fine. Because with denormalized data, we're probably trying to look at how we can see those relationships more quickly. So with denormalization, we tend to duplicate data in ways that make it easier to query or easier to understand, whereas normalization is typically used for an operational purpose. Like, this is what is supporting our application as it's live. And denormalization separates data into separate tables or separate structures so that we can use references to tie that together when necessary. So if you're familiar with SQL, and we'll talk a little bit about SQL, things like table joins are going to depend on normalization. In fact, if you think about fully denormalized data, we don't have to think about table joins. They don't have to exist because all of the data that we need is in one place. So normalization requires this idea of joining tables together and referential integrity, because we have to read and update, pretty frequently. But denormalization doesn't really require us to make updates very frequently, if ever. With denormalization, updating is more complex. With normalization, retrieval is slightly more complex. So, we're really using these two tools for different purposes here. It tends to be, when we're looking at machine learning, we're probably going to be working with denormalized data very frequently, because we don't have to do as much work for these joins, and we can actually read data very quickly and very efficiently. So just kind of an example here, if we have several normalized tables on the right, you can see we might have courses, we might have instructors, we might have who's matched to which one. Whereas on the left, you can see here we're going to have to duplicate data: CS1520 web development, CS1520 web development. If we have to change the title of that course, now our system is going to have to update many records. Now, our computers can move very quickly. They can do these things very fast, but that's wasted effort if we don't need to use it. And the way I always look at this is, if your operations start to take longer than a millisecond and you need to do more than 1,000 of them in a second, you start to fall behind, and that's a problem that tends to exacerbate very quickly. It tends to kind of blow up very quickly. So that can escalate. So we typically want to do things efficiently in computing, even though our computing power is really high. So here's somewhere where we can avoid updating that title many times. If we can normalize it, then for an operational purpose, that may be very useful. So you can see here denormalized data on the left, where we have potentially lots of duplicates in our not only IDs but also descriptions of the data. And then we have normalized data, where we have tables, and we have maybe association tables or ways that we're kind of referring to both of these, so we can match things in this manner. Now, when we get into keys and IDs, this is going to be an important part of this conversation, because we're going to have different keys that we use to actually match data up. So foreign keys, we'll start at the bottom. I don't always organize these top to bottom, I guess. So foreign keys are going to be where we are referring to another table. So, when we're dealing with normalized data, we often need these foreign keys so that we can identify what this data is matched up to or what it's associated with. Now, we also have natural keys and artificial keys. Natural keys in our data are going to be things that exist outside of the database. So they may not actually look that natural, but they have meaning outside of the database. The database does not define their meaning. Artificial keys are keys where the meaning is defined within the database. So any type of serial number or any type of sequence that's generated by the database, doesn't necessarily mean anything outside of the database, but it's used for this referential integrity. It's used for foreign keys to refer to other things, and it simplifies how we actually associate. Like it's very common for names, for example, to be duplicated across multiple entities. There are many people named John Smith in the world, so in this situation, that's not a very good natural key. So we have to think about how we can use keys to identify those people, and sometimes that is the only way we can do that effectively is with an artificial key. The other nice thing about artificial keys is we can use them, or we can build them with data types that are easier to analyze. It's much easier to match an integer to an integer than it is to match a string to a string. So artificial keys tend to be something that's simpler. It's simpler to manage to match a simple string than it is to match a very complex or long string. So we tend to use artificial keys for efficiency and for just being able to identify things within a database. So keys are ways to identify data. This is something that allows us to kind of create some way to say this is the data, this is the unique record that we have here. It's defined by this. It allows us to distinguish John Smith here from John Smith here if those are two different people. Primary keys are a unique identifier for some particular entity, some record, some entry of data that we have. And a natural key, like we said, has meaning outside of the database. It occurs in the world. It occurs naturally, maybe not so naturally. Maybe it is somewhat man-made, but it has some kind of meaning outside of the database, where an artificial key is one of these sequences, serial numbers, something like that, that only really, we've generated it for the purposes of the database and not much else. Foreign keys are primary keys that refer to other data in our database. So one other interesting and useful feature of structured data is we often index structured data. Indexing allows us to look data up very quickly. So, if we want to query data, if we want to select all of the records in a database that match a particular criteria, where age is less than 27, for example, indexing allows us to do this very quickly. It allows us to kind of look at this particular field or this particular value in a database record, and then, create data structures that allow us to search it and find things very quickly. So different databases take different approaches to indexing. It's not like there's only one way to index, and that's an abstraction that we don't have to think about. I think typically it's important to know that indexes are pretty efficient, so when we want to do things like queries or we want to do things like table joins, they work pretty quickly. So how it actually is implemented, less important than knowing that it's pretty efficient. Probably a big O1, big O, maybe log n operation to perform these queries or to perform these joins. And then indexing allows us, the major reason is it allows us to take this column and join all the data over here to all the data over here in a way that allows us to match that up and create a new maybe view or a new just output from this data that makes sense. Metadata is another important concept when we're talking about structured data. Metadata is data that describes your data, so it's data about data. Information about your tables, your columns, your data types, your constraints, your indices, your relationships, all of this is metadata. And metadata isn't limited to structured data. We may have metadata whether data is structured or unstructured. So we can think about metadata as just some way that we are describing our data, whether that is a constraint or whether that's an attribute, or maybe that's just like a key or a keyword or something. All of these things can be metadata when we're working with data. Now, a lot of these concepts become important when we're talking about relational databases versus data warehouses. Data warehouses tend to be tend to be a place where we're going to inspect a lot of our data, where we're going to look at data very frequently. So a relational database management system is typically something that's online, it's operational, it's responsive, it updates quickly. So a relational database management system is something we might use to support one of our applications that's like a web application, or maybe it's the back end data for our iPhone app. It can be a lot of different things. Whereas a data warehouse is typically not something that's online, probably not updated frequently, if it's ever updated. Data warehouses are often populated with data dumps from a database, but these are optimized for reading. We want them to be really fast for all sorts of reading because we typically use them for reporting and analysis. So one thing that you'll see in relational databases is this ACID concept: atomicity, consistency, isolation, and durability. So atomicity basically means that when we make an update, when we sequence a bunch of updates, we can make those atomic. Either they all happen or they don't happen. We can kind of treat sequences of activity as if they're one thing. Databases are also consistent, so that from one update to another, we're not screwing things up. We're not changing the structure. We're not breaking the database, for example. Databases are also isolated. One read or write doesn't affect other read or writes, so that they, these different operations can essentially be separated from each other. And then they're durable. When we make an update, it's persisted. If the database crashes, that's still there. If we've identified that this atomic update has happened, we can be sure that it's still there. So ACID concepts aren't so important in a data warehouse because we don't care too much about updates. All we really want to be able to do is read effectively. So, a data warehouse could be as simple as a text file. There's usually much better tools around them to analyze, or to understand them. But, a data warehouse is going to be something that we don't want to update frequently, if at all. So, ideas of like atomic updates, that doesn't really have a whole lot of value. Isolating transactions, we don't really have transactions or anything like that in a data warehouse, so we don't have to think about it. So relational databases typically are normalized databases, like they are something where we don't want to have any type of duplication, because we want to update and we want to make sure that not only are our updates efficient, but they're also secure. We don't miss things that we need to update. So they tend to be relational because they are denormalized in this way, or they're typically normalized in this way. There's an error on that slide. Typically normalized relational databases. I'll fix that before I share the slides. And then data warehouses are typically very denormalized, and they don't have relations. Typically with a data warehouse, we might have every single bit of information we need about a particular entity in a single table. So those joins don't have to happen. The data warehouses tend to look more like output, but we can use them very efficiently because we can read records very fast. We don't have to go doing these joins, which typically are pretty efficient due to indexing, but again, it can be wasted effort. So we want to make that very efficient, especially when we're training a machine learning model on potentially hundreds of thousands or millions of records there. So that can be pretty important. So that's all we have for now on this particular topic. We will explore further and further on structured data before we get into unstructured data, but hopefully this was a good overview of how you can work with databases. If you've already worked with some databases, this is probably a little bit redundant, but if you haven't worked with databases, I'll see if I can find some materials so that you can go and read up on those and understand them, because those concepts of structured data will be important when we get into SQL queries and how we can use that for potentially models like forecasting models. Thank you for watching.